Okay, confidence interval for the mean. Most people find this chapter so easy after the last one. So if you're struggling with chapter 8 still, you can still do chapter 9, and most people find it pretty simple. So what is the confidence interval for the mean? First of all, suppose you want to estimate the mean number of hours college students are working per week. So you could take a survey of 200 students and ask them how many hours they worked last week. And you could calculate a sample estimate, X bar, which is 24.8. So you've taken your 200 students, put their numbers into StatCrunch, how many hours they worked, and asked it to find the mean, and you got 24.8. They call that estimate a point estimate because it's just one point of data. Okay? Now, when you're using sample data for estimating population data, there's a possibility that your random sample doesn't reflect the population, and they call this error. Error doesn't mean that you did anything wrong. It just means you happen to get a sample that's very low or very high, and that happens because of randomness. So in order to have a normal distribution of the sampling mean, we merely require that the sample be random, because the methods used to construct the confidence interval work regardless of the shape of the population or the sample size. So in other words, we're not going to require here that n be bigger than 30 because we're using a confidence interval we call the t-interval. And the t-interval doesn't require that n is bigger than 30. It lets us use small samples. Sometimes that's all you have are small samples, particularly if you're in a field like biology or something where you're kind of measuring something real. You might not have that many samples if you are, say, counting frogs or looking at the pH of certain plants or something like that. You may just have small samples to work with. Get rid of that. So to allow for a more precise estimate of the parameter, we're going to use what we call a confidence interval estimate and a margin of error. Now, all of this language is new and a little weird, but it's actually super, super easy. You just got to trust me. So a confidence interval for an unknown parameter consists of an interval of numbers based on your point estimate. It has a lower bound and an upper bound, and it's written in the form, in parentheses, lower bound, comma, upper bound. It's also written as X bar plus or minus a margin of error, where the margin of error is the number that defines the lower and upper bounds of the confidence interval. So we can write it either way, and it's the same thing. We can have X bar plus or minus a margin of error. Sometimes people will call it E. I tend to call it ME, so I remember it's a margin of error. And that's also another way to write the same thing, which is lower bound, upper bound. It's just a similar way to write that, and you'll see that as we go on. The width of the confidence interval is the difference between the upper bound and the lower bound. Okay, so the width is the upper bound minus the lower bound. And what it looks like is, suppose here is my confidence interval, and we have a lower bound here and an upper bound here. My X bar is actually right smack in the middle. This is the margin of error. So the upper bound is the margin of error added onto X bar, and the lower bound is x bar minus the margin of error. So these two lengths are the margin of error. The length of all of them together, they call the width. Does everybody get that? So margin of error is on either side of x bar, and that tells us what the width is. Here's an example. The 95% confidence interval for the mean number of hours students work is, in parentheses, the lower bound is 24.63 and the upper bound is 24.97. So if I was going to draw that the way I did before, here is 24.63, my lower bound on a number line, and 24.97 is my upper bound here. So lower bound, upper bound, right smack in the middle is my x bar. This x bar is 24.8. It's exactly in the middle of the two of them. Now, if we just had those two to find x bar, we can just find the mean of the lower bound and the upper bound, which means lower bound plus upper bound divided by 2. And that'll give us the x bar right away. The margin of error is the difference between those two, 0.017 and 0.017. So it's the same thing as the upper bound minus x bar, or same thing as the x bar minus the lower bound. It's that distance. And the width is here, which we could find by either saying 2 times the margin of error, or by doing the upper bound minus the lower bound. So there's lots of ways to calculate these things. If you draw them out, you can usually figure them out. Okay? Oh, I'm noticing I'm not seeing your list again. I don't see any questions though. So there are 2 other vocabulary words. One is the confidence level. The confidence level represents the expected proportion of intervals that would contain the parameter if a large number of different samples are obtained. So the level of confidence is usually 95%, 98%, or 99%. And the opposite of that percent is called the level of significance. So if we have a confidence level of 95%, the opposite of it, 1 minus 95%, is 0.05. So what does that mean? So the confidence interval is formed by taking the x bar you found, my sample mean, and using StatCrunch to find an interval. There's a formula, you don't want to know it. So we get a confidence interval. Now someone else could get a different sample mean because they talk to different people. It's close to yours, but it's not exactly the same. And they're going to get a slightly different interval because their x bar is different. And if I took all the people taking stats this semester and said, go ask people how many hours they're working, you're all going to have slightly different x bars. Maybe some are the same, but they're mostly different. Okay. If we took all those and found all the different intervals in the whole world that it's possible to get, then 95% or 95 out of 100 of them actually contains the sample mean. Or sorry, the population mean, mu, the population mean. So you've gone out in the wild and asked people how many hours they work. You came up with an interval And maybe the mean's actually in there and maybe it's not. But if you do this method correctly, 95 out of 100 of them will contain the population mean. If it doesn't contain the population mean, then mean is going to be close to the interval. It's not way off, it's just not exact. And the reason it's not as exact is because samples. Samples are random, so some of them are going to be off. Some of them will be too high and some of them will be too low. This is really pivotal, which is how do we report the confidence interval? We want to say very carefully that we're 95% confident that the mean number of hours that all students work is between the lower bound and the upper bound. So this phrase, we are 95% confident, is really, really important. Yeah, I'm taking a picture every time I write on the PowerPoint, and so that's going to definitely be posted for you. Good question. Those I post really quick because it's easy to post. The other thing takes a lot longer. Okay. So what you're looking for is this phrase, and you're going to always write out the phrase, we are 95% confident, or something like that. I am 100% confident, or 95% confident. The researcher is 95% confident. You're never, ever going to talk about probability or anything like that. Don't do it because it's wrong. Okay. So I'll get a shot of that and clear that. So we're 95% confident that the mean number of hours that all students work is between 24.63 and 24.97 means if we use these methods to find 100 samples, so 100 sample means and 100 different intervals, 95% of them would actually contain the mean of the population. Can we have an interval without the population mean? Sure, because it's just one sample. So the margin of error depends on 3 factors: level of confidence, sample size, and standard deviation of the population. So let me just go through those a little bit. First of all, the level of confidence, 95% or 99%. If I want 99 out of 100 to contain the mean, then I just make them bigger. So they're just going to be wider intervals. Here's a narrow interval for 95%. And here's a wider one for 99%. And just by making them wider, it's going to catch more times where the actual mean is. So wider goes with a higher percentage. Sample size. As we know, this having a better sample size makes the standard deviation smaller, which means we get a smaller margin of error. The bigger the sample size, the less you're going to get a wonky X-bar. Remember when we said that? If you have one weird value, it's not going to count as much if we have a bigger sample size. And then the third is the standard deviation of the population. If a population is spread out, then there's more places that mean could go. So we need to have a wider interval with a more spread out standard deviation. Okay.